So very good morning. Today we will start the chapter number second, periodic properties. In previous lectures, we have completed the chapter number one, atomic structure. Now we will go for the chapter number second. Okay. So I am sharing the screen. If it is visible clearly, then kindly give me response.
Sir, yes, sir.
Chapter second is the
Yes, sir. Periodic properties.
periodic properties. Just a minute. Now, in previous class, we have just completed the introduction of the periodic properties. Okay. Now, in case of periodic properties, there are number of elements has been discovered at the start of the 19th century, but it was quite difficult to remember all the elements. Okay. So earlier 56 elements has been discovered. Then after that 65 elements, then 109. So in this way, uh, day by day, the researchers are discovering the elements every year. So, in order to remember all the properties of the elements, it was quite difficult. Therefore, the concept of arrangement of elements in a specific table has been given. So, it was observed that the elements which are having the same property are placed in one group. The elements which are having the different properties like physical properties and chemical properties, these are placed in another groups. So history of the periodic table tells that in the year 1871, Mendeleev arranged the elements according to increase in their atomic mass. So Mendeleev has placed the elements on the basis of increasing in atomic mass. So how he placed the elements? Mendeleev in the year 1871 placed the elements with increasing order of their atomic mass. For example, atomic number of hydrogen is 1 and mass is also 1. Helium is atomic number 2, mass is 4. So on the basis of increase in mass, the Mendeleev placed the elements with increase in their masses. So according to Mendeleev, the elements with similar properties were put in the same group, means within the same group. For example, the elements which are having the similar properties are placed in one group. The elements which are having different properties are placed in another group. Metals are placed in one group, then non-metals are placed in another groups. Similarly, the atoms which are having the similar physical and chemical properties are placed in one group and other elements are placed in other groups. So on the basis of increase in atomic mass, these elements are placed. But it was observed that this method of arrangement of elements on the basis of their atomic masses was not correct, because it was observed that the elements which are having the different physical and chemical properties are coming within the same group. On that basis, the arrangement of elements in the periodic table on the basis of increase in atomic mass is discarded. Means the elements which are placed on the basis of their atomic masses are placed in the same group, but these elements are found to have the different physical and chemical properties. So this indicates that the method of placing the elements on the basis of their atomic masses is not correct. So in the year 1913, Moseley arranged the elements in the periodic table on the basis of their increase in atomic number. So elements with the similar properties were put in the same column or same group. So it was observed that with increase in atomic number their properties are also going to change. जैसे कैसी डेफिनेशन है पीरियोडिक मींस जैसे जैसे टाइम चेंज हो रहा तो वैसे वैसे क्या होगा जैसे आपके लेक्चर्स है लेक्चर्स आर हैविंग द डिफरेंट क्लासेस ऑन द डिफरेंट टाइम्स सो जैसे जैसे टाइम चेंज होगा तो क्या होगा लेक्चर भी चेंज होगा सो दिस इंडिकेट्स दैट it indicates that with change in time the classes are also going to change. The same concept is applicable here. With change in atomic number, the physical and chemical properties of elements are also going to change. जैसे जैसे atomic number change होगा तो elements की physical और chemical properties भी क्या होंगी change होंगी. So on that basis, Moseley placed these elements with increasing in atomic number. तो मोस्ले ने क्या बोला था कि जो एलिमेंट्स का फिजिकल और केमिकल प्रॉपर्टीज है उनको उसने एक ग्रुप में रखा और जो एलिमेंट्स का फिजिकल और केमिकल प्रॉपर्टीज डिफरेंट है कौन सी बेस पे डिफरेंट होगा ऑन द बेसिस ऑफ एटॉमिक नंबर चेंज होगा तो फिजिकल और केमिकल प्रॉपर्टीज भी क्या होंगी चेंज होंगी सो ही प्लेस द एलिमेंट्स इन द डिफरेंट groups on the basis of change in their atomic number. For example, if we take the example of beryllium, okay, atomic number of beryllium is 4. Then if we take the example of boron, atomic number of boron is 5. यहाँ पे atomic number क्या है बेरिलियम का 4 है और बोरॉन का एटॉमिक नंबर है 5. तो एक से चेंज हुआ एक एटॉमिक नंबर जो है चेंज हुआ एक यूनिट से एटॉमिक नंबर चेंज हुआ सो एवरीथिंग इज ओके Is there any problem? Muhammad Shada?
No, sir.
Okay. So I will ask you during my class to anybody. Okay. So it was observed that with change in atomic number, their properties are also going to change. जैसे जैसे एटॉमिक नंबर चेंज होगा तो उनकी प्रॉपर्टी भी क्या होगी चेंज होगी तो बेरिलियम एटॉमिक नंबर 4 है लेकिन वो कौन से ग्रुप में है कौन से ब्लॉक में है एस ब्लॉक और एस ब्लॉक एलिमेंट्स पूरे क्या है मेटल्स हैं ठीक है बोरॉन एटॉमिक नंबर क्या है बोरॉन का एटॉमिक नंबर 5 है बट बोरॉन कम्स अंडर विच कैटेगरी नॉन मेटल्स तो एक यूनिट चेंज होने से क्या होगा इनकी प्रॉपर्टी भी चेंज होगी सो विद एलिमेंट्स विद सिमिलर प्रॉपर्टीज वे आर पुट इन सेम ग्रुप अब बेरिलियम ग्रुप में जो है बेरिलियम के जितने एलिमेंट्स है बेरिलियम फैमिली के तो वो पूरे एलिमेंट्स की प्रॉपर्टी क्या रहेगी सेम रहेगी देन हाइड्रोजन फैमिली एलिमेंट्स बोरॉन फैमिली एलिमेंट में जितने हैं जैसे बोरॉन फैमिली एलिमेंट में कौन कौन है बोरॉन एल्यूमिनियम गैलियम इंडियम एंड नेक्स्ट कार्बन नाइट्रोजन then carbon silicon germanium tin and lead. All these elements are having the similar physical and chemical properties so on that basis Moseley have arranged the elements which are having the similar physical and chemical properties within the one group and other elements which are different by one unit they are placed in another group so one by one we will see here next is just like that so what are the periodic properties first we will see the periodic table in periodic table what happened this periodic table consists of 4 blocks okay so I will annotate I will draw so this block is S block these two groups comes under the S block group number 1 and group number 2 this block is P block okay these elements comes from group number 13 to group number 18 okay these elements are the P block elements now in between S and P block which block is there yes this block is D block and on the lower side of D block it is the F block element okay these are two rows are sorry. These two rows are the F block elements so these are the fundamentals or these are the basics of the periodic table has been divided into 4 blocks S block elements then P block elements D block elements and F block elements these are the F block elements now here we will see next this is the periodic table this periodic table indicates just I will erase what I have drawn here wait Now screen is clear or not? Yes.
Clear, sir.
Okay. Now this is the periodic table.
Clear, sir.
Okay. Okay. Wait. This is the periodic table. This indicates what? When we go from left to right in the periodic table, atomic size is going to decreases. Atomic size is going to decrease from left to right. If we proceed from left to right, just look to my arrow what I am moving from left to right. When we move from left to right, the atomic size is going to decreases. And when we proceed and when we go from top to bottom, see to the left hand side, the atomic size is going to increases. Okay, why it is going to decreases and why it is going to increases? When we go from left to right in the periodic table, the new electrons are added within the same shell. How many shells are there in first period? Only one shell is there. Okay, now how many shells are there in second period? Second period is having two shells. So when we go from lithium to beryllium, beryllium to boron, carbon, nitrogen, oxygen, chlorine and neon, तो क्या होगा यहाँ से सेकंड पीरियड में अगर हम प्रोसीड हो रहे लिथियम से लेके नियॉन तक की, तो एटॉमिक नंबर क्या है लिथियम का 3, बेरिलियम का 4, बोरॉन का 5। तो जैसे जैसे नए नए इलेक्ट्रॉन ऐड हो रहे तो नए इलेक्ट्रॉन कौन से शेल में आ रहे, वही शेल में, पहले शेल में 2 इलेक्ट्रॉन, दूसरे में 1 इलेक्ट्रॉन। फिर इसी तरह बेरिलियम में रहेंगे, पहले में 2 इलेक्ट्रॉन, दूसरे में 2 इलेक्ट्रॉन। तो नया इलेक्ट्रॉन कौन से ऑर्बिट में आ रहा, सेम ऑर्बिट में। ऑर्बिट चेंज हो रहा क्या, नहीं हो रहा। तो ऑर्बिट चेंज नहीं हो रहा, शेल नंबर कांस्टेंट है या ऑर्बिट नंबर कांस्टेंट है, उसकी वजह से क्या होगा, नए इलेक्ट्रॉन जब ऐड हो रहे हैं तो इलेक्ट्रोस्टैटिक फोर्स ऑफ अट्रैक्शन बढ़ रहा, जिसकी वजह से एटॉमिक साइज कम हो रहा। When we go from left to right in the periodic table, there is no change in the shell number. New electrons are added within the same shell. That's why the atomic size is going to decreases from left to right. But when we go from top to bottom, if we go from top to bottom, yes, when we go from top to bottom, when we go from top to bottom, it was observed that the new electrons are added within the new shell. यहाँ पे कितने शेल है हाइड्रोजन में, देन लिथियम में कितने शेल है, 2, सोडियम में 3 शेल है। तो नए इलेक्ट्रॉन कहाँ पे ऐड हो रहे हैं, इलेक्ट्रॉन्स आर ऐड, यस kindly mute yourself. I'm requesting all of you kindly mute yourself. Okay, so when we go from top to bottom, new shells are there, new shells are added, so new electrons are added within the new shell. तो जैसे ऊपर से अगर नीचे गए हम ग्रुप में तो नए शेल्स ऐड होंगे, नए शेल ऐड होंगे तो इलेक्ट्रॉन कौन से इसमें आएंगे, नए शेल में। इसीलिए ऊपर से नीचे जब गए हम ग्रुप में तो एटॉमिक साइज बढ़ता और लेफ्ट से राइट में जो तो एटॉमिक साइज डिक्रीज होता। So when we go from top to bottom, atomic size increases, and when we go from left to right, atomic size decreases. Okay. So next, this is the example of the atomic size or atomic radius. Now, if we observe the period number 1, this is the hydrogen atom, it is the helium atom. Okay, there is not too much difference between the hydrogen and helium. Why? Because both belongs to the first period and both are having the only one shell. One is, this configuration is 1s1 and helium is having 1s2. But when we go from top to bottom, okay, now go for top to bottom, the lithium, sodium, potassium, rubidium and cesium. Now the atomic number of lithium is 3. How many shells are there? कितने शेल है लिथियम में, शेल कितने रहेंगे, 2 शेल। पहले शेल में 2 इलेक्ट्रॉन, जस्ट आई विल एक्सप्लेन हियर। ओके, so first shell is lithium is having, first shell is having, sorry, I will draw it by this. First shell is having 2 electron and second shell is having 1 electron. Okay, for lithium. For beryllium, first shell is having 2 electron and second shell is having again 2 electron. Then what is for boron? First shell is having 2 electron and second shell is having 3 electron. So new electrons are added within the second shell. So it is the nucleus, it is first shell, okay, and it is the second shell. So new electrons are added within the second shell. क्योंकि शेल नंबर चेंज होगा क्या यहाँ पे, बोलो शेल नंबर चेंज होगा क्या?
No, sir.
No, because new electrons are added, because only two shells are there, that's why new electrons are added within the same shell. तो यहाँ पे जैसे जैसे शेल एटॉमिक नंबर चेंज होगा तो नए इलेक्ट्रॉन कौन से ऑर्बिट में आएंगे, उसी ऑर्बिट में या उसी शेल में आएंगे. तो जैसे जैसे हम लेफ्ट से राइट में अगर जाते हैं, लिथियम से बेरिलियम, बेरिलियम से बोरॉन, कार्बन, नाइट्रोजन, ऑक्सीजन, क्लोरीन, नियॉन, शेल नंबर कांस्टेंट रहेगा, शेल नंबर चेंज नहीं होगा, और नए जो इलेक्ट्रॉन आएंगे वो नेक्स्ट शेल में आएंगे, मतलब उसी शेल में आएंगे, सेकंड शेल में. अब उसकी वजह से क्या होगा, यहाँ पे जो न्यूक्लियस है, न्यूक्लियस में क्या है बोलो, न्यूक्लियस में पॉजिटिवली चार्ज प्रोटॉन्स हैं, और ये जो इलेक्ट्रॉन है निगेटिवली चार्ज, इसमें अट्रैक्शन क्या रहेगा, बढ़ते जाएंगे. अट्रैक्शन क्या होगा यहाँ पे, बढ़ेंगे. इलेक्ट्रोस्टैटिक फोर्स ऑफ अट्रैक्शन विल इंक्रीज. ड्यू टू इंक्रीज इन इलेक्ट्रोस्टैटिक फोर्स ऑफ अट्रैक्शन, द एटॉमिक साइज फ्रॉम लेफ्ट टू राइट इज गोइंग टू डिक्रीजेस. इसीलिए लिथियम क्या है, सबसे ज्यादा एटॉमिक साइज है. लिथियम का एटॉमिक साइज सबसे ज्यादा है. उससे कम कितना है, बेरिलियम. उससे कम बोरॉन, कार्बन, नाइट्रोजन. ठीक है, बट बोरॉन टू कार्बन देयर इज नॉट टू मच डिफरेंस देन नाइट्रोजन, ऑक्सीजन, क्लोरीन, नियॉन. ओके, similarly from nitrogen to oxygen the size is not too much different. This we will see in next slide. Okay, but when we observe what happen, ऊपर से अगर नीचे गए तो यहाँ पे क्या है, शेल कितने हैं बोलो, हाइड्रोजन में कितने शेल है, हाइड्रोजन में शेल कितना है, ओनली वन शेल है. देन लिथियम में शेल कितना है, दो शेल, पहला शेल और
Two shells.
ये दूसरा शेल. देन सोडियम में कितने शेल है, तीन शेल, पहला शेल,
तीन से
दूसरा शेल, फिर तीसरा शेल, क्योंकि ये तीसरे पीरियड का है. ऊपर से एटॉमिक साइज क्या होगा, ऊपर से नीचे एटॉमिक साइज बढ़ेगा.
Increase होगी, sir.
इंक्रीज होगा सर.
वेरी गुड. सो आई विल erase all what I have written on the slide. Okay, just wait. So when we proceed from left to right, atomic size is going to decreases, and top to bottom atomic size going to increase. So this
Increases.
indicates that, what indicates that, the atomic size. Next slide. So what is atomic radius? In previous class also we have seen, when we have we are observing the offline, we are going for offline class, we observe what is atomic size or atomic radius. Size of an atom is the distance from the nucleus to the outermost electron. What is the atomic size or atomic radius? The distance from the center of the nucleus towards the so suppose it is the nucleus, it is having proton and neutron, and suppose here it is the shell. So this shell is consist of electron. So distance from the center of the nucleus toward the valence shell is known as the atomic size. Now I will tell you what is atomic size. This is what atomic. What I have drawn by the blue line. The distance from the center of the nucleus toward the valence shell electron, or distance from the nucleus to the outermost electron. तो इलेक्ट्रॉन का और ये न्यूक्लियस का जो डिस्टेंस है, दिस इज नोन एज व्हाट, atomic radius or size of an atom. So okay, got it or not? What is atomic radius? Kazi Adiba, what is the definition of atomic radius?
So the distance between the center of the nucleus of an atom and its outermost shell.
Shell, not shell, it is electron.
Yes.
Outermost electron. The distance from the center of the nucleus to the outermost electron is known as atomic radius. Now we will go for the next slide. So this slide is clearly indicates what, just a minute. So this slide, when we observe this slide, and all these are the colorful elements, it indicates that when we go from top to bottom, atomic size increases. Here also second group also the same, atomic size increases. Here third one. So this indicates, all this indicates what? If I draw this one, okay. So from top to bottom, atomic size increases. Here also the same pattern, atomic size is going to increases. So top to bottom atomic size increases. Here also same. Here also same. So what happened here? From top to bottom atomic size increases, and from left to right atomic size decreases. Okay.
Decreases.
So left to right atomic size decreases. Here also atomic size decreases. Okay. So it is very helpful for understanding. This slide is very helpful for understanding the atomic size and atomic radius. Now we will go for the next slide. So what is the types of the radius? So I have already explained three types of radii are there. First is covalent radius, second is Wonderwall radius, and third is ionic radius. So what is the word covalent radius? The word covalent itself indicates that this is related to the covalent bond. This is related to the covalent bond. So half the distance between the center of two bonded atoms joined each other by means of which bond? Covalent bond. So half the distance between the centers of two bonded atoms join each other by a single covalent bond. The distance can be measured. Okay, only 10 minutes are there. Okay, so within 10 minutes we will complete it. After that, I will also share the new link for the continuing our classes. Okay, only 10 minutes are there for completion of this class. So half the distance between the center of bonded atoms which are bonded each other by means of covalent bond. So distance can be measured by means of which techniques? X-ray diffraction and spectroscopic techniques. So radius of atom is defined as, what is the radius of atom? The internuclear distance in in the bonded atoms. Internuclear distance बिटवीन द टू बॉन्डेड एटम्स. अब जो भी डिस्टेंस है दो एटम के न्यूक्लियस से अगर काउंट किए उसका हाफ जो डिस्टेंस रहेगा दैट इज कोवेलेंट रेडियस. दिस कैन बी अंडरस्टैंड बाय मींस ऑफ दिस taking this example. So what is covalent radius? See the example of this one. Half distance between the center of two bonded atoms joined each other by means of which bond? Covalent bond. This can be measured by which techniques? X-ray technique and spectroscopic method or spectroscopic technique. Who is this admit? Now suppose these two atoms are bonded to each other by means of which bond? Covalent bond. Okay, now this part is the center of the, oh no, sorry. Now suppose here this is the nucleus of the, this I will draw by means of red line. Okay, suppose here it is the nucleus of the atom H, hydrogen atom. Now this will be the nucleus of atom B, that is hydrogen atom. Now the distance from the center of the nucleus of one atom to the distance from the center of nucleus to the other atom which are bonded by means of which bond? Covalent bond. This distance is nothing but the internuclear distance. This distance is the internuclear distance. Now half distance of this internuclear distance is covalent radius. इसका जो हाफ रहेगा वो क्या रहेगा? Covalent. So I will draw it by just wait. So this is the green. इसका जो हाफ रहेगा पूरे जो न्यूक्लियस उसका हाफ डिस्टेंस रहेगा कोवेलेंट रेडियस. ये जो ग्रीन से जो मैंने ड्रॉ किया यहाँ से, so this what I have drawn by means of green, that is known as internuclear distance. That distance is known as internuclear distance. This will be more helpful if I draw by means of red. So this distance which I have shown you by means of this distance, जो distance मैंने ये रेड से बताया हूँ, ठीक है? क्लियरली देख रहे हैं आप? नजर आ रहा?
Yes, sir.
Yes, sir.
ये जो distance है, this is the,
Yes, sir.
okay. Now Covalent radius is applicable to only the covalently bonded molecule. Okay, the atoms which are bonded by means of covalent bond, the covalent radius is applicable to covalently bonded atom. Is there anything? Okay, this is the covalent radius. Okay, internuclear distance का half अगर किए तो वो जो रहेगा covalent radius. Okay, next is ionic radius. Next is ionic radius. So by taking the example of H2 molecule, we will understand the covalent radius. So covalent radius is defined as half the internuclear distance of covalently bonded atom is known as covalent radius. Now, two hydrogen atoms are bonded to each other by means of covalent bond. So this is the one hydrogen atom. It is another hydrogen atom. This radius or the distance is known as covalent radius, and half of that covalent radius is covalent. Sorry, half of this internuclear distance is the covalent radius. For example, what is the distance between the center of or nucleus of hydrogen atom 1 and hydrogen atom 2? It is 0.74 angstrom. Okay, now half, what is the half of 0.74 angstrom? That is 0.37. This 0.37 is nothing but the covalent radius. Okay, so I will okay, so 0.74 divided by 2, that is 0.37. So 0.37 is nothing but the covalent radius of the H2 molecule. Okay, this is the definition of the covalent radius. You can easily explain by taking the example of H2 molecule. How you will explain? Yes, anybody? Bushra Tainiyat. What is the definition of covalent radius?
So it is the half distance of intermolecular distance between two molecules.
Between the two atoms, not molecule.
Okay, sir. Two atoms.
Simple definition of covalent radius is half the internuclear distance of two,
Two atoms.
two atoms bonded by covalent bond. Two atoms bonded by
Yes.
covalent bond is known as covalent radius. Okay.
Covalent radius.
Very good. Next is the next we will go for another slide. So everybody is clear.
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
Next is the Wonderwall's radius. What is the Wonderwall radius? Wonderwall, half of the distance between the two similar atoms belongs to neighboring molecule of the same substance in solid state. इसमें covalent में और इसमें distance difference क्या है? This is also the half the distance between the two similar atoms. But here the two atoms are not bonded to the same molecule. इसमें क्या है? वन रॉल रेडियस में half the internuclear distance between the two atoms bonded to two different molecule of the same species or substance. For example here, ये एक H2 मॉलिक्यूल है पूरा और ये दूसरा H2 मॉलिक्यूल है. ये एक हाइड्रोजन एटम है, ये हाइड्रोजन एटम है. दोनों हाइड्रोजन एटम कौन से बॉन्ड से अटैच है? कोवेलेंट बॉन्ड से. ये दोनों हाइड्रोजन भी कौन से बॉन्ड से अटैच है? कोवेलेंट. इन दोनों में ये हाइड्रोजन एटम एक मॉलिक्यूल का है और ये हाइड्रोजन एटम दूसरे मॉलिक्यूल का. इन दोनों का जो डिस्टेंस है, एक मॉलिक्यूल का एक हाइड्रोजन एटम, दूसरे मॉलिक्यूल का दूसरा हाइड्रोजन एटम. सो इन दोनों का जो डिस्टेंस है, इन दोनों का डिस्टेंस रहेगा ये वाला, उसका हाफ, दैट इज नोन एज वंडरवॉल रेडियस. हाफ द distance between the two similar, sorry, van der Waals radius is defined as the half the distance between two similar atoms belongs to two neighboring molecule of the same substance in the solid state is known as covalent radius. Okay, now just wait. Sir, I am doing online lecture. शुरू है online lecture. 5 मिनट वेट करो. So this is known as van der Waals radius. What is van der Waals radius? Half the distance between two similar atoms belongs to two neighboring molecule of the same substance in solid state is known as covalent. By taking the example of H2 molecule, what is the distance between the hydrogen atom of one molecule and hydrogen atom of another molecule? It is 1.98 angstrom. So half of the 1.98, that will be nothing but the 0.99. Okay, so that will be the covalent radius. So always the covalent radius or van der Waals radius value will be always more than the कोवेलेंट रेडियस. वंडरवॉल रेडियस की हमेशा वैल्यू क्या रहेंगे, कोवेलेंट रेडियस से ज्यादा रहेंगे, क्योंकि ये दो अलग अलग मॉलिक्यूल के दो एटम्स का डिस्टेंस है. नेक्स्ट इज द आयोनिक रेडियस. ओके, सो व्हाट इज द आयोनिक रेडियस? आई थिंक हाउ मेनी व्हाट इज टाइम नाउ? यस,
12:05, sir.
12:05. So how many only 10 minutes are there. Okay, so next is the ionic radius. So what ion comes from, how the ions are formed? When the one atom loses electron, it get converted into ion. When the other atom accepts the electron, it get converted into ion. Okay. So if the suppose these two atoms are asking or undergoing conversation, ये दोनों क्या कर रहे हैं, बात कर रहे हैं. कैसी बात कर रहे हैं? I lost electron.